All right, guys, so you can see I went ahead and drew sort of a globe shape here, and I need you to go ahead and do the same thing on your piece of paper that you're using to record this diagram down on. So make a circle and go ahead. It doesn't have to have the continents in there. Don't worry about that part, but make the circle and then draw those lines across that are at 60, 30, 0, 30, and 60, just like you see on mine, okay? Because you're going to need those for today, and we're going to add a little bit more into them as we go. All right, so this is global wind belts, and global wind belts are high up in the atmosphere, so we're not going to feel global wind when we feel wind down like outside of our house, for example. Those are going to be local winds, local breezes. Global winds are higher up in the atmosphere, and they help to kind of move weather around, and certainly they're always going in the same sort of directions. They're predictable. So we're going to go ahead and start and label. The first thing we need to do is identify our equator. So hopefully you know, but I'm going to label over on this side my equator. So there is our equator. The equator is going to get direct heating from the sun. It is the most direct in this region of anywhere. So I'm going to go ahead and take this line and kind of put a red line there because it's getting direct heating. All right, the next thing we're going to identify is our poles. So we've got two. We've got North Pole and we've got South Pole. So I'm going to make a little, why is that whole thing moving? I don't want to move that. All right, let's start there and do it. Okay, so we've got North. No, we don't. My goodness, I'm losing it. That wouldn't be North, crazy teacher. We've got South Pole down there. And up here, we've got our North Pole. Now, these should be the most indirect areas that we will have because the Earth on an axis and because we have the angle at which the sun is reaching that. It is not going to be as direct, therefore those regions are always cooler. The equator is always going to be warmer. All right, so now let's talk about some of the wind belts that are created. Well, actually, they didn't put a 0, so let's put in a 0 in my diagram here. This equator line is 0 degrees latitude. Remember that from our latitude and longitude conversations earlier in the year. So that is 0. Now, we're going to make some little lines because they don't have any on our diagram about 5 degrees north and 5 degrees south of the equator. So I'm just going to kind of eyeball it and sort of make it. It doesn't have to be perfect, but that's kind of in our location here. All right, so in that region, it is known as, I'm going to go off to the left because I can't really do it very easily on the right-hand side because I already have equator written. And I'm actually going to go and change where I wrote that 0 so that it's easier. Oh, actually, there is a 0. Never mind. We've got a 0 over there. I wasn't looking. All right, so on the opposite side, we've got the doldrums. That's this 5 degrees north and 5 degrees south of the equator. Those are known as the doldrums. There's going to be very, very light wind in the doldrums. Hardly any like really strong winds because it's all evenly heated in that area. So the doldrums are very dull, dry, not much wind going on there. All right, now we're going to actually start out at the poles, okay? And we're going to work our way in because the wind kind of shifts back and forth because of this thing called the Coriolis effect, which we'll get to. All right, so let's start at the South Pole. So South Pole, my winds start coming out from the pole sort of in this direction, okay? My winds are coming out there. And just like up at the North Pole, we're going to have the same. So it's coming sort of from an easterly direction, moving out. Both of these polar winds have the same name. Remember, directions of wind are determined from where they blow from. So these guys are called polar, and they're coming from an east direction, so they're polar easterlies. So my polar easterlies are here, and they're going to be up at the top. Polar easterlies are here. Okay, so far so good. We've got our doldrums hanging out by the equator. We've got polar easterlies heading outward from the poles. Well, now, again, we've got this Coriolis effect. So things kind of bounce back and forth and back and forth. Well, at 30 degrees south and 30 degrees north, from 60 to 30, we have another wind belt. This one's actually really important because this is one of the belts that are our prevailing winds. They're prevailing westerlies. So they're going to actually bounce back toward the poles. So they kind of curve back this way. Remember, if we didn't have any spinning and everything was evenly heated, we wouldn't have these crazy diagrams. All right, and then this direction, they go back this way. So between 60 degrees north and 30 degrees north, and between 60 degrees south and 30 degrees south, we have prevailing westerlies. I'm going to switch the color because I know it's a little bit crowded to try to help you see that. So we've got prevailing westerlies. Right here. And down below, prevailing westerlies. Right there. All right, so far so good. Okay, so we've got one more wind belt to put in for this. The next one, again, is going to switch positions or switch directions, I should say. So I'm going to go back to my black arrows here. We're going to, again, come from the eastern direction. So these guys are northeast. And these are southeast. And they are trade winds. So let me get another color to make it easier to read here. So these are north, east, trade winds. And these are southeast. Trade winds. All right, so I know this seems a little bit complicated. It will make a lot more sense when we define everything and when we work with it. But the reason it bounces all around like this, again, has to do with that Coriolis effect from the spinning and looking at high and low air pressure, because at the equator, we have low air pressure. So we have rising warm air at the equator. that then the cooler air from the poles kind of starts working toward taking that void or that area. So the wind basically the wind rises from the equator and kind of slowly works its way toward the poles, sinking, getting higher pressure as it goes. And then the high pressure from the high pressure from the poles heads back toward the equator. And it's sort of a cycle that keeps going like that. All right, guys, so this is the end of the diagram part, but we are going to do some notes on the next video. So make sure you still have this paper so we can define it a little bit more.